Of the four phases of matter, solid, liquid, gas, and plasma, which contains high-energy ionized particles, we will be focusing on how solids behave with respect to electric charges and forces. The nuclei in solids form a fixed structure. They are locked into position. Solids are classified as conductors, insulators, or semiconductors. In conductors, some electrons are free to move throughout the solid and are not bound to any single atom. Electrons in insulators are more tightly bound but can move short distances. Semiconductors act either as conductors or insulators and are the foundation of the transistor, which is the basic building block of cell phones, computers, and most of the electronics that we now have. Since electrons can move freely within a conductor and they have like negative charges, they will repel each other until they are spread apart as far as possible. This means that for any conductor in electrostatic equilibrium, these electrons, or any excess charge, will reside on the surface of the material, the surface being the furthest away that they can get from each other. Examples of conductors that behave this way are copper wire, which you see on the left, transmission lines, which transmit our power from one area to another, and gold. The electrons in an insulator are bound very tightly to their atoms, but under the right circumstances, for example, rubbing of a rubber rod with animal fur, they can move short distances, establishing small areas of positive or negative charge, like the ruler in the bits of paper shown earlier. Examples include glass, plastics, and ceramics. The ceramic you see over here, this is used most frequently in power lines where it can insulate transmission lines which conduct the electricity from the power plant to your home and from lightning strikes that may hit the transmission towers. The electricity will not go past these ceramics.